Hello everyone, today's lesson is chemistry at a crime scene, and this is investigation chemical reactions 4.1, 4.2, and remember, you are just watching through, you're not stopping to do anything until you get to the notes at the end. So just as it stops in Edpuzzle, you will stop with it and answer the question. So let's jump on in. Okay, solving a crime. Today you will use what you've learned to identify an unknown substance. We've done this before. Your knowledge today of chemical reactions will help the police in investigating a robbery. So we're going to use our knowledge to help the police investigate a robbery. Scientists actually solve mysteries. Scientists are sometimes asked to use their knowledge to help police collect and analyze evidence from a crime scene. If there is a trial, a scientist may be called as an expert witness. So let's look at this letter from Dr. Samara Young, our lead chemist. She is writing to all of us, or student chemist, about someone who stole the Lavoisier diamond. So please follow along as I read aloud. There's been a robbery at the Westfield Museum. This morning, the museum staff discovered the rare and expensive Lavoisier diamond was missing. When police arrived, they found a hole had been made in the glass display case where the diamond was stored. Next to the display case, they found a plastic container that was half full with an unknown substance. Police think that the thief may have used some of the substance to make a hole in the glass and may have accidentally left the rest of the substance behind. The chief of police has asked me to help them identify this unknown substance and determine who could have used it to steal the Lavoisier diamond. As you have recent experience in working with the community of Westfield, I am turning the case over to you. I hope you remember what you have learned so far about chemical reactions. I think you will need to use your knowledge to help the police crack the case. So now that we know what we're doing, let's go on. All right, so Chapter 4 question is, who might have used the unknown substance to steal the diamond? That's what we have to figure out today. Okay, so remember, when there are colors representing all the different atoms. They're going to be different colored for a reason. They represent different types. You have different repeating groups of atoms. We have the hydrogen, the oxygen, the sulfur, the chlorine, the magnesium, the fluorine, and the calcium, and they're all mixed together in different ways, or represented in different ways to represent different types of substances that may have cut the glass. What we know so far is, first and foremost, the diamond thief used an unknown substance to make a hole in the glass. The second one is the diamond thief did not use all of the unknown substance. Some of the substance was left behind at the crime scene by accident, which was lucky for us. Okay, so as you are doing your work today, whether it's on in Amplify or on paper, I need you to fill out the paperwork in complete sentences. Always do your best work, please. This is just an example of what you'll be doing today, so please always do your best work. All right, so we're going to look at the suspects. The police have identified 3 possible suspects who ordered suspicious substances from a local chemical supply company and may have been able to produce the hydrofluoric acid. So Pat is a sculptor who ordered sulfuric acid and calcium fluoride. Alex is a gardener who ordered sulfuric acid and magnesium chloride. And Tracy is a chemist who ordered purified water and fluorine. So this is a little bit of background knowledge that will help you when you go to solve the case. So a list of corrosive substances that may have been the cause of the hole are hydrobromic acid, hydrofluoric acid, iodine monochloride, and perchloric acid. And when you look at the properties over here, you will see they all have different properties that will help to identify the substance. Okay, so why do we use models? Remember that things that are too small to see can be studied with models. This model provides information about the atoms that make up the hydrofluoric acid. So as you can see, repeating groups of H and F will make the hydrofluoric acid. So that is just one way to use a model. So here is a substance reference guide. You are going to use this as you are trying to solve the mystery. And as you get more information, notice we have 2 more boxes of information. You'll want to remember that it is so important to get as much evidence and important information as you can when trying to solve a mystery or a problem. You will be able to evaluate using more evidence as it becomes available. So this is one of the tools you will be using today. You will be creating, making hydrofluoric acid with these different molecular models. And remember, you'll want to color this so you can get the crayons or colored pencils or markers, whatever you choose, to make this molecular model, because this is going to help you solve the case. And what is really going to help you solve the case along with that modeling tool are the evidence cards. These are the science seminar evidence cards that you will have to present when you come to our science seminar. So as you can see, all the different evidence cards will give you an idea of who the suspect was and what they did. For example, you'll use this sorting grid, and this is one way to use this. You will put evidence cards, after you cut them out, you will lay them on the different squares to represent if it was evidence against or for. So your chapter 4 notes, if you can open up to your chapter 4 notes at the end of your packet, that's what we will do to finish off this lesson. Okay, so chemists can play a role in analyzing crime scene evidence. Evaluating evidence quality is an important aspect of making a strong argument. And finally, corrosive substances can damage when they come into contact with other substances. They can cause damage. All right, so looking at models, scientists can use models to determine whether or not a claim is possible. Also, scientists need to revisit and revise these models when new evidence becomes available, and it always is. And finally, discussing evidence and ideas with others helps build new understanding. And scientists can change their minds when presented with convincing evidence. So you don't always have to stick to what you thought you had figured out. When new evidence becomes available, you will change your mind or change your observations or change your hypotheses, and that is okay. So assignments to do for today are to complete pages 60 through 74 in your packet, and you're going to do page 60 and 62 from Amplify Lesson 4.1. Remember to look at the bottom of the page to see the exact part. You're going to use pages 63 through 65, 68, and 73 and 74 to do Amplify 4.2. I should have put that there. Then you will cut out page 66 to place on page 71 the sorting grid to help you analyze the evidence. Then you will write your notes, if you didn't already do that, for chapter 4 on page 27 of your chemical reactions packet, and you will take the mastery check of number 8 for Amplify 4.1, 4.2 when you're done. Please do your best. Good job today, guys.